Uh, Good afternoon, everybody. Welcome for this session on exploration of. We abbreviate it to NICIP, which is much more shorter thing. It's because the expansion is pretty more. It's mouthful. In LFN. So when we say about LFN, we refer to Linux Foundation's Anuket project kind of thing. So Anuket, if you just for a quick introduction, it's an umbrella project where it earlier we used to have OPNFV. And after some time, the CNTT came into picture, came up with the specifications document. Then OPNFV and CNTT combined to form Anuket in LFN. So under Anuket, we started a project called Thoth. So that was mainly on NFV using AI and ML for NFV use cases. It started almost a year and a half back. So we started creating, we want to create basically the models, the usable models kind of a thing. We found that there was a lot of work on frameworks, AI and ML frameworks, but there were no models for telco use cases. So we wanted to create real models that could be used by telcos. So that was the main idea behind this Thoth project, and we created a failure prediction model. So we created one model called failure prediction based on the available data set. And also we built some tools for that thing. So one of the tools we built was whoever are new to this domain, so if they can, the tool will ask set of questions to that user. Then at the end it will suggest what kind of AI and ML technique to start with to solve the problem kind of thing. So this is mostly targeting the end users who are not familiar with the AI and ML. They don't have to worry about all the what kind of the models to start with and use it. This tool will help them to begin with this AI and ML thing. But the problem that we Thoth faced was the availability of data set. So we kind of struggled. We spoke with a lot of telcos, though that was a showstopper for us. So that is when the Thoth decided to transform. That's when China Mobile also joined the project, and they wanted to create this intelligent collaborative platform kind of thing. So first Weisen will talk more on the NICIP, and then I will continue how we are trying to solve the problem of how do we generate the data sets kind of a thing. So one of the idea was to using AI and ML again to solve the problem that the technique that's used in AI and ML called as GANs or generative adversarial networks that are usually used to create images. You would have seen like fake images, and those things are created using GANs. So we want to use GANs itself to create telco data, like infrastructure data and logs kind of a thing. So that was the main idea thing. So I will be talking more on that part thing. So first I will allow Weisen to elaborate more on what is this NICIP.
Thank you. Thank you, Rao. Yeah, I'm fine. Good afternoon, everybody. So first of all, I want to thank you, Rao's introduction. So for today's presentation, actually, this is not my project. So the project leader, Huang Lin and Yang Yan cannot come to join this meeting in person. So I will give the presentation instead of them. And as you guys know, here we have the content outline of today's presentation. First of all, I will go through the background, and then I will talk about we have 4 implementation ways to how to join this project, and we also have currently we have 2 practice. One is anomaly detection and root cause analysis of network cloud device. And Rao will take care of the rest of this, the other practice. So we hope that through this topic sharing, we can build a better intelligent network ecosystem together and explore network scenarios and data empowered by network. So here before we get started, we want to give you guys some background of what is intelligent networking and what is intelligent networking ecosystem. So here we list the definition, two definitions of these two terms. So because of time limited, I will not go into the details. And then these slides will show our motivation and action for building the intelligent network ecosystem. So as you guys know, the currently bottleneck problems of network intelligence technology including data, algorithm, and so on. So for this project, in order to solve those problems, the Dr. Junlan Feng, she is the board of the chair and a proposal at LFN 1EEF that it is better to connect industry organizations in LFN and establish joint working group for open source network innovation. So here we have a diagram for this project. So the first layer, you can see this very hot topic like the 5G for AI and AI for 5G. And the second layer is the AI model and the capabilities. So in this layer, we have CV, computer vision, NLP, and speech, and sensing, all kinds of AI models at this layer. And then on the third layer is intelligent computing units. In this layer, including general HCU and model CUs. And for the bottom layer, we have all kinds of resources, like the data, environment, and knowledge. So for the next, I will talk about the NICIP implementation ways. So here we have our project goal and project form. And so our project goal is to gather operators, vendors, research institutions to share model scenarios and data, R&D resources according to common network intelligence requirements of industry. Jointly construct network intelligence algorithm models, then created a network intelligence collaborative innovation ecosystem. And for this project, we have 5 items of project works. The first one is according to the requirements of algorithm models, ecosystem construction of the network intelligence collaborative innovation project. We will build a Gate platform. So as you guys know, the Gate is open source. So at here we will build based on the Gate lab, and for this Gate lab we'll store the files, data, and models. And the second one is use scenarios. So we will collect network intelligence scenario requirements from operators and organize a scenario requirements review and submission and launch. So currently we also call for researchers according to their AI background and do some development and submit the models to the project. And the next one is according to the requirements of network intelligence scenarios. We hope scenario requirements bring data so that we can jointly build a network intelligent scenario data set for industry. Like you guys know, right now for the operator, the data is not open. So I think we try to use this way to solve this problem. So in this part, in the last part, we will try to dynamically evaluate the work. So and then we also will do the ranking for the result. So at the same time, to make this project implement normally, and contributed to better understand the working mechanism of this project. We have designed the project implementation plan here. So as you can see, we have 5 stages to promote project operation and circle iterations. So the first stage is prepare for publication of problems. And I think at this stage, we will collect the network intelligence problems from the vendor, from the company, from the organization. And the second stage is a model provider participation stage. Usually the model providers check the network intelligence question. This question usually comes from the first stage. And then they download the data and train their model and upload the result to our, as I mentioned before, is a GitLab. And the third stage is inference result evaluation stage. So this one is after the developer submits the result, it will trigger the process. That is, this process will evaluate the result of the algorithm. And the next one is excellent model sharing stage. So for this stage, we'll ask the model with the final result ranking, such as top 5, will be requested to open and share to the technical committee, and also to share to the public actually. And also the technical committee is responsibility for review and merge the result. And the last stage is a contributor award stage. So for this stage, we will issue to contributors to network intelligence problem and model provider. And the technical committee will recommend and review the final reward list. So here we have the detailed description of the project. So in order to minimize project maintenance cost and achieve the goal of collaborative innovation ecosystem construction in this project, we choose to use GitLab as a basic maintenance platform. The reason is this GitLab is strong and open source. In the previous process introduction, we have the 3 rules will be involved in the project, including the problem definer, model provider, and the reviewer. So in GitLab, we'll create a different group based on the different rule. Here we show the grouping suggestions in GitLab. The top group will include reviewer members from the technical community. And there are 2 subgroups. One is a problem definer and one is a model solution provider group. So under the different group, we'll create the corresponding projects here, shows the project design. So for the problem definer, will belongs to as we mentioned before slides, the problem definer project belongs to the problem definer group. So we suggest each network intelligence problem is maintained as a separate project, mainly considering that the data sets will be stored with the problem definition. If multiple problem definitions are stored under one project, the project set will be very huge. So it makes it difficult to download the project. So in addition, for the problem solver, he may only care about specific problems. So at the same time, considering the verification of dataset types and the unstructured data storage capabilities. So we may need extra storage. For the model sharing project belong to the model solution provider group. This slide shows the project directory examples. So you can see from picture at here. And for the last one is model ranking project belongs to the reviewer group. So usually a review ranking file will be put under each problem directory, which stores model real-time ranking result, and the file will refresh automatically when the inference result merged in GitLab. This usually need to be done with the help of the GitLab CI automatically trigger. So for the next slides, I will talk about one of our practice. It's named anomaly detection and root cause analysis of network cloud device. So we have released an ITU competition scenario and plan to release anomaly detection problem recently. So we are glad to release the first competition. Its name is here. And this one is held by Linux Foundation, Anuket, and the China Mobile together. So here is a background of this practice. So with the arrival of 5G, a variety of the services have emerged which are accompanied by generation of the massive data, and also putting forward health requirements for the operation and maintenance of telecommunication networks. So in order to improve the stability of the network, it is necessary to detect the anomaly of the network cloud device, and then analyze the root cause of the anomaly to find out the potential risks. Log as a valuable data resource itself contains a variety of performance indicators, including network performance indicators related to the entire system load and key indicators strongly related to the business. So in the traditional exception detection, the operation and the maintenance engineer can only filter and check possible exceptions by writing rulers, which mainly depends on the domain knowledge of expertise. With the increase of 5G network scale and the complexity, the distributed system and the dramatically increase of data quantity and the complexity, the traditional analysis methods that consume huge manpower have become impossible. Therefore, in order to solve this problem, we need to use machine learning and deep learning related technologies to improve the accuracy and the real-time of anomaly detection and the root cause. So here we have, as I mentioned above, the core task of this practice is to detect the anomaly and analyze the root cause of the real-time data generated by NFV distributed system. So usually, the competitors need to conduct a series of pre-processing and the log analysis, training and upload and the model according to the existing offline log set provided. Then make a normal prediction about whether there is an exception and conduct a root cause analysis to give the exception time, exception details. So here we have shown the data set. So the data set is a collection of log from multiple nodes and components of the network cloud device. So the entire data set is divided into two parts. One is, as usual, one is a training set, one is a evaluation set. Sometimes we also have the test set, I think. All log files keep the original log message body. In the first part, the content of the file is a series of log generated during the normal running on the system. The second part is composite of multiple log sequence files. The contents of each file are log fragments of the system running for a period of time. And there may be exceptions. The competitors are expected to give whether the log in the file are abnormal and the line number of the exception. There is no restriction and the data processing competitor can freely process according to the algorithm needs. So here shows the set of format and a series of logs. For the result submission, the competitors need to analyze the log data that generated by the real system and submit the result to the system. In the table shows here in the left table shows the file format. The submission must be in strict accordance with the format of the result table. So here we also give the result example. If you want to know more detail, you can visit this link. These slides, we will talk about the evaluation criteria. So the overall evaluation is divided into 3 parts. The first part is coverage and accuracy evaluation. So accounting for 70% of the total score. The second part is the timelessness evaluation, accounting for 15% of the total score. And the last part is performance evaluation, accounting for 15% of the total score. The calculation formula of each part is given at the bottom here. So here we give the timeline of this practice. The competition will start from the 2022 November to 2023 February. During this period, the competitor should finish the registration result submission, and we will also evaluate the result and give the final ranking. So from the 2023 March, we will enter into the award phase. In this period, we will organize the excellent model provider to present their solution and give the final rewards. So for the next lesson, I will hand over to the Rao. Yeah.
So yeah. Weisen just explained what they're planning to do. What I'll be covering now is what we actually did with LFN Anuket project in Thoth. As I mentioned in the beginning, once we did the failure prediction solve the problem, we realized that getting the data is a big issue, right? So we thought of, hey, why don't we use ML itself to generate this data, and we thought of using GANs to synthetic generation of this data. And we first tried internally. We could get like 70% accuracy, close to we wanted to generate the infrastructure metrics, the CPU, the RAM, the interface metrics, and all these infrastructure metrics to be synthetically generated by GANs. Then we thought of collaborating with ITU. So ITU has this program called AI for Good, where every year they conduct this competition where they invite the participants throughout to either very similar to what Weisen explained. You can become a host, you can propose a problem, and competitors from different parts around the world will try to solve the problem, and then they'll be given an award, kind of a thing. So then we decided from Anuket, Thoth, hey, why don't we become the host of one of the problems, and we proposed this as a problem, synthetic data generation as a problem to ITU, and it got ended. I think 2 days back I completed the evaluation of the teams that had submitted the problem using GANs. It's pretty good. So there is still a good hope that we can use GANs going ahead. I think. Yeah, so the problem is basically to synthetic observatory data generation using GANs. What we did was, let me give so what we did was we deployed a Kubernetes cluster in one of our Anuket testbeds that we have provided by Intel. And also at the same time, China Mobile also deployed a similar Kubernetes testbed in their environment, and we use these chaos tools that Kubernetes has. So Kubernetes has bunch of these tools which will generate workloads, kind of a thing, which will try to emulate real workloads like a telco workloads, or it could be enterprise workloads. So we try to use these kind of chaos tools to generate these kind of workloads on this. Litmus is the one which one of the things. Yeah. Other things I'm not able to recollect, I will get back to you. So Litmus is the one which we used, and we also used StressNG as another tool. We containerized StressNG and created the pods using StressNG, and within the StressNG, I think StressNG is a very popular Linux tool for generating workloads, right? So we use the StressNG to emulate. Yeah, it doesn't generate network traffic. So for network traffic, we created a separate application on top of. So both the StressNG and the traffic generator tool, we combined into a single container and created a workload kind of a thing, which will be matched close to the network function workloads kind of a thing. So we use this tool, these kind of containers to run in this Kubernetes cluster and run for quite a few hours and collected the infrastructure metrics. So this infrastructure metrics we provided to the competition. So whoever wanted to use this metrics and try to use it with the GANs and generate the synthetic data. Okay, so that was the main idea, and so we submitted I think almost 6 to 8 months back. Now there were 3 or 4 teams competed, and they submitted their outcome. And we evaluated there is a potential, but the good thing with ITU is you can repeat this year on year kind of. That's what a lot of hosts do with ITU. They try to optimize year on year the problem, the quality of the solution kind of a thing. So we plan to in Anuket also we plan to continue this process year on year, so that we can by next year the GANs can perform better in generating the synthetic data. Because I don't see in maybe in a year or so telcos sharing the data in public kind of a thing. So we will have to rely on generating this kind of synthetic data itself. So but one of the problem in Anuket that we are currently working on is to anonymize the data thing. So that which will help, so we are building a tool to anonymize data anonymizer thing, so which can help the telcos to share their data thing. So currently we are trying to anonymize 5 different things that is not mentioned here. I'll just give a quick overview. One is on the region, the country name, whether there is any country name or the city names are there should be removed kind of a thing, or any organization names are there should be removed, any domain names are there should be removed, and IP addresses and MAC addresses should be removed. So we are targeting to do these kind of 5 to that as
are you just removing them, or are you doing
the scrambling. So we give an option either to remove or to scramble kind of a thing. So either to if there's one country name, move city name, you change it to or scramble it to a different name kind of a thing.
You can do shifting. There's
yeah. So the option will be given to the user, so that could be done. So that kind of anonymizer is currently the work in progress. We have LF has an internship program, right? Under that, one of our interns is working on that anonymizer problem with this in this Thoth. So once we are with this both this anonymizer data and this synthetic data, we intend to with Thoth to solve this our data availability problem in this NFV use case. Yeah, so this is just an explanation of what I just. So AI for good is one of the place. If you are also looking for any data set to work with telco use cases, I think, right? AI for good has some good amount of problems. Still, a lot of them are again generated by simulators and emulators, really not from the real world deployments. But for example, from KDDI, they say it's very close to the real world, but still it's an emulated data set. So we completed this one. I just mentioned like 2 days back we submitted this results. We'll be announcing the winner for this thing. Yeah, so how to participate in NICIP or the Anuket Thoth. As I mentioned, once we transform, once we face with the problem of the data availability, now like Thoth is slowly moving to this creating that NICIP, which is the idea is to use this what the competitions do. Why don't we collaborate in a way the competitions do, right? So that's the main idea behind the NICIP. So the best way is to please join us. We meet every Friday at 6 a.m. Pacific. So all the details are available in wiki, Anuket wiki. Yeah, so and Weisen explained China Mobile will be opening up this whole NICIP platform on the GitLab, where the idea is you can either become the problem proposer, you can propose a problem, or you can work on solving those problems, or you can be a reviewer committee. So you have these 3 options to participate with the NICIP. You can pick, for example, if you say, hey, I can be a good reviewer, I can review. If you have the models developed, you can be part of the reviewer team, or you can say, hey, I have these problems, you can be the proposer of the problem. So you, as Weisen explained, the 3 options, you can pick and come and say, hey, I want to be in which of this group, and NICIP is more than happy to welcome you into this thing. Yeah, so there's all the link is there, wiki.anuket.io. Anuket project is the LFN, as I mentioned. In that wiki, we have all the details about this thing. I would like to welcome you all to come and join this group.
Wondering if, for getting the cloud data, I'm not sure why that's that difficult to get a hold of.
It's not, I can tell you, because I'm on the.
Yeah.
I'm working with Thoth as well.
So she's Anuket, by the way, Anuket TSC chair.
I get the NFV, but
No, it's the network data is what you really need, and that's proprietary.
okay.
Yeah, cloud data, that's.
Because I thought the problem was for the cloud infrastructure.
Yeah.
No, the problem's for the network.
No, even in the infrastructure data, right? Even the infrastructure data you cannot get. Telcos are not okay to share with the infrastructure data because it may contain some of the sensitive information,
Sure,
IP addresses, and
it still has to be cleansed.
correct.
We even do that for our own sandboxes. We don't allow production data to be openly available to anybody.
Right, there's two components. You're absolutely right. The production data needs to be cleansed. The other issue is that the data is if you had a set of Verizon's data and you had a set of AT&T's data, it would be different.
But if I was
So the algorithms wouldn't necessarily work.
Well, see, that's where you want the data sets though to be somewhat standardized. That's the part of the value chain of it.
Correct.
And if you're using it based off of Anuket, then I think you would want it to be then based off of what do we expect the infrastructure to provide in a standardized way. So this is very much playing in to like in ORAN's working group 6 on a standardized cloud.
Correct.
We don't go to that level. That Anuket's taken it down a lower level, I think.
Yeah, Anuket's taken, well, we have the reference architectures, we have the 2.
Because all we do is specify that there will be counters, that there will be
Yes.
alarms, but we don't say what those counters
Yeah,
are,
you're
or
right.
what those
Yeah,
alarms are.
I mean, that's
Yeah,
that's the level
very
that
similar.
Anuket's down.
Right, exactly. And so if you have that data,
Correct.
then you should be able to try and get that data. I mean, we
Except
could even
that
use our own cloud in OSC to generate some of that, right?
True.
The counters and the alarms might be returning different data.
Different data values. It could, and it
Different
could be
data
based off
values,
of
yeah.
different resources, that type.
Correct. See, even if you say, hey, it doesn't matter whether you, for example, there are very most popular tool is collect D, which most of the use cases that are run. Whether you any of these popular data collectors kind of a thing, whether it's Zabbix or collect D or any of this, whatever the specification they use, or even at the higher level from the Prometheus, if you can give me the infrastructure data, but it is not available today. Even we tried with all telcos requesting them for this data. Even the infrastructure data, it's very difficult to get.
Yeah, but we have an cloud instance in OSC Lab that's not telco specific. It's generalized data.
But there.
You get a sample set, but it's not going to be large. It's not a big cloud,
Yeah.
right?
Correct.
It's not a lot of workloads yet.
Yes. Yes.
Well,
So
that's the other thing.
that's the other thing. Yeah.
AI, you need a large sample set.
True.
otherwise you get garbage.
Exactly.
And as she always tells, garbage in, garbage out. Then.
You might have a seed that you can use, because if you're still using that as your seed for GAN, then you can have the one that would generate the good data, and you'd have the other agent that's trying to inject the errors, right?
Correct.
I mean, that's the two opposing things in the GAN's model, right?
There is a discriminator thing which will actually do the thing, which takes the real and the synthetic and try to give me the error, whatever the error that we design, the discriminator, and keep optimizing the discriminator output kind of a thing. Yeah.
And David, that conversation we had earlier today about the dev, the dev and the tools. I mean, we built a lab that has real production data.
Yeah, we have our own lab, and it has real, it's not really real.
Well,
but
we
close.
actually run the real production network through the lab.
Oh, see, we have two different models. One is the lab, and then we have what we call innovation zones, which is where we cordon off a small blast area where we have a small damage area if something goes wrong, and we test in production.
Yeah, we have those too, but the lab I was talking about it's called the Network Engineering Production Lab, and what I mean, we use it to test things that have already gone wrong out in the
I
field.
think we at least used to have something. We had a production support lab, because testing like performance systems, you can't get enough volume in a lab. And so we had
We do,
we
because
had to
we're-
take a copy off the
Right,
network.
yeah, I
feed
mean,
it
we're
in
doing a
order to see
digital
volume.
twin, to do it.
Yeah. So.
But you need that large volume, because,
Yeah.
I mean, you can test till the cows come home in a lab, and if you don't have a big enough data set, you're never gonna find where it's gonna fail over.
That's
Correct. Yeah. So yeah, from in Anuket, we are still trying to first generate these using these kind of tools like chaos tools I mentioned. Try to make it as close as possible to a CNF or a VNF kind of the way they behave, the pattern, the network data generate, the CPU consumption, the RAM consumption, the memory consumption. We're trying to emulate that one so that the emulated data is at least good enough kind of a thing.
Right, but the first pass, I know last year, it was garbage. It came out.
Yeah. So yeah. So again, so now.
Another question I had though on your process was that it seems to me like you open the competition, but you're only going to, so to speak, publish the ones that win, are awarded, right? And there has to be an agreement coming into the competition that they will publish. Otherwise, you might wind up with people with proprietary algorithms trying to win, but not publish. So they get the accolade, but they don't publish, and that's.
So
If they agree to compete, they agree to publish.
correct. Yeah, this is a very, we have this discussion for a lot on this one, but how feasible it is still an open problem kind of a thing. So it's still a thought process kind of a thing, whether we will be successful because see, ITU is a neutral platform, so that's why people are okay to go and share with them and.